In this video, we will work with the Nordic Thingy 53 multi-protocol IoT prototyping platform. And let's take a look at its description from Nordic Semi website. You can see that it has dual core wireless system on chip, which is NRF5340. And we will be running embedded machine learning models on this device. We will use NRF Edge Impulse app on our mobile phone, and we will connect to the Edge Impulse website to build our model. We will go through all those processes. You can see the protocols that the Thingy 53 is supporting, and it has lots of sensors. We will take a look at the light sensor in this application. However, it has an accelerometer, magnetometer. We will take a look at the Nordic Thingy 53 product description. You can see that in detail there are environmental, color and light sensor, low power accelerometer, buzzer and microphone. And about its system on a chip, it has dual core. One is for application, the other for network. And power management IC. And the applications are mainly machine learning. We will use it for machine learning as well. Actually, we will do a classification. And here is our Thingy 53. I connected it via USB to the laptop, but you don't have to for the beginning of this sample for this project. It already has the Edge Impulse app firmware installed, so let's turn it on from this switch. You will see that the LED, RGB LED will be on. Now this is our phone, and we downloaded and installed NRF Edge Impulse app. And once we open it, you can see your device as Edge Impulse. Actually, that's our Thingy 53. And once we tap on it, we can connect to it. Now we are connected, and you can see its sensors, accelerometer, microphone, inertial, light, and environment. And you can use these sensors in combination, and these are listed here. So you can use two sensors and obtain data from them at the same time. And you can go to the upper side of this tab, and once you go to the data acquisition tab, you can see your project. And once you tap on the plus icon, you can start to record new data. So let's try, for example, let's label it as light 1, and we can tap on the sensor and we can choose the light sensor. You can increase the sample length from 10 seconds to more, and this is your frequency. Once we tap on the get sample, the sampling has started, and once the sampling has finished, it will upload the sample to the Edge Impulse. Let's have another sample for 10 seconds. So this is our second sample. It's going to be labeled as light 1 again, and it will be uploaded to Edge Impulse as soon as it's finished. You can see that it's success. You can choose testing, you can choose training, whichever sample you want. Now we are in Edge Impulse Studio website. Once you create an account, you can go into this view. So I will skip the wizard and try to continue from the dashboard. You can see that our first impulse seems like 34% complete because we have gathered some data from the light sensor, and you can see other sections as how many devices are connected, how many data is collected. You can see that that was 20 seconds because we had 10 seconds of light sensor data. This is the Thingy 53 that we registered to our project. Once you click on data acquisition, you can see that the data collected is 20 seconds again, and you can see that the train test ratio is 100 to 0. And from the collected data, you can click on the samples, and there's a menu that you can perform on those samples. In the extended view, you can see that the length of the sample, device, when it's created, and the sensors. And once you tap on the sample, you see that this is the RGB values and there is an infrared value at the bottom, that's 0. That was the second sample. This is the first sample. And this is the second sample. You can see that the RGB values are very low in this one compared to the first one because I had turned off my desk lamp, so that's the reason for this. Now I will be deleting these two light sensor records because I will be getting new samples from Edge Impulse app. Now I've placed the Thingy:53 in front of the LCD screen, so I'm going to get samples from the TV, such as news program or TV series or sports programs like football, basketball, or snooker, and I'm going to put them into the training set or test set. Now that we have placed our Thingy:53 in front of the TV, I can start recording new data. So as I'm watching the news at the moment, I'm going to label this as news, and I'm going to select the light sensor. I'm going to start sampling by tapping on start sampling. And it has started. It's going to sample for 10 seconds, and it's going to upload this first sample to Edge Impulse. So you can see that upload is success, and our file is right here in the training set. And I will continue doing this for news for, let's say, tens of samples. I will do the same for football. I will do the same for basketball, snooker. I will do it for TV series. So whichever classes I would like to have, I will have to get some training set and the test set for these samples. Now I've finished gathering the samples from the light sensor for TV series, for news, for snooker, basketball, etc. And let's continue with the Edge Impulse Studio. So we can check our device's status. We have our Thingy:53. We can take a look at the data acquisition. You can see that we are in the training data section and we have 16 minutes 40 seconds of data in training, and you can see in the pie chart that we have news, basketball, football, snooker, etc. And we've already seen the collected data section previously, but you can see that we have lots of samples this time. And we can take a look at the TV series, for example, the RGB values and its change over time. For example, we have news, we have snooker. This was TV series and sample from TV series. This is news. If you compare the two, you can see that the news values are more stable. In snooker, it's also seems like the RGB values are nearly constant. And for basketball, we have these RGB values. We can see their change over time, and you can compare them if you'd like. And we have football, for example, samples from football can be seen here. Again, some news. These are the samples, and in the test data, the total duration is 3 minutes 20 seconds. And in the pie chart, you can see their distribution: basketball, football, snooker, news. But in this one, in the test data, I don't have TV series, so there seems to be a problem. We can click on this one and see. You can see that it says TV series class is a poor train test split ratio because we don't have any test samples. But we can overcome this difficulty very easily. We can change data, its label from training to test. recorded some samples from some movies. You can see that I will check some TV series from the training set, a few of them, 5 of them, let's say, and I will move them to the test set with this button, and I confirm that. And you can see that we don't have that warning anymore. Actually, it still says TV series has a poor train test split ratio, but that's not the case. It's in a good position now. You can see that 68% to 14%, sorry, 86% to 14%. Let's add 2 more to the test data set. And the training test ratio seems okay for all the 5 classifications that we have. By the way, you can see that I've already told you that we had movie samples in the test set, but we don't have them in the training set because I wanted to see what it will correspond to when we test the movies in this trained model. Okay, so in the create impulse section, we will continue with the time series data. This shows the window size, window increase, and the frequency. Once we click on the add processing block, we don't need anything for our model because raw data will be fine. And we continue with the RGB data only because we don't need the infrared data. Actually, it's nearly constant in all the samples. It's at 0. And we are only focused on the RGB values, so I don't have to get the infrared value of the light sensor, so I will delete that. So 3 input axis RGB will be fine. And I will continue with add a learning block. I cannot save at this time. I will add a learning block. You can see that it's already recommended, the classification. That is what we are going to do. We are going to learn patterns from the light sensor, and we will try to classify new samples on our Thingy 53. And we can save the impulse. We have 5 output features: basketball, football, news, snooker, and TV series. I save the impulse, and once we click on the raw data, you can check the parameters and the features that are extracted from them. And you can take a look at the labels, 5 labels that we have. You can also check the samples on this drop-down box. Actually, we don't have to do anything new at this point. But we will continue with generate features. We will click on generate features. And on the bottom part, you will see the progress, feature generation output. You can see that we see the nearest neighbor method there. Actually, you don't have to know that much about the classification and the neural networks that we are going to use. You will see that in a couple of minutes. And the feature explorer, you can see on the right hand side. And you can see that this is snooker, this is TV series. And we will continue with the classifier. So these are the suggested values. And you can see that the neural network architecture is consisted of the input layer, 15 features. You can see on the bottom side. And in the hidden layers, we have 20 neurons as a layer, and another layer as 10 neurons, and the output layer has 5 classes, because we have 5 different classes to be done. So we start the training. You can see the progress. And you can see that it's using TensorFlow Lite. You can take a look at the TensorFlow site to get a better understanding of it. It's used for machine learning, and it's also used for embedded machine learning, and that section is used in this part as well. So job is completed. So if we scroll down, we can see the performance of the model. You can see that the accuracy is 96.2%. And if you take a look at the confusion matrix, you can see that basketball has the lowest performance, we can say, because it's 78% is classified correctly. And the other ones, football news, snooker, and TV series, seems to be fine. But remember that we didn't use the test set yet. This is all training set. And you can see that which one is classified as correct, which one is classified as incorrect. It's listed in the Data Explorer. And you can see on the bottom the on-device performance, inferencing time, RAM usage. So if we scroll down through the studio, you can see that we can use this Eon tuner. Actually, I won't be using it, but you can take a look at what it does. You can choose your device or your CPU. You can retrain your model here. I will skip this one as well. I will go to live classification. And in this one, since we have made our training, we can check with a test example. We can select one, for example, let's select the movie, which we did not have in the training set. So be careful about it. So I just wanted to see which one it's going to map into. You can see that uncertain, 9 out of 10, and 1 out of 10 for TV series. So we don't expect any good result in this one in movies, but let's go to, for example, TV series and select one sample. You can see that it's classified as TV series 10 out of 10, so it's good. And let's have snooker. It's classified as snooker 10 out of 10, so that's a good result as well. Let's have news. And you can see that it didn't classify well, so it's uncertain 7, 1 basketball, 1 news, and 1 TV series. And another football sample. It's classified as football 10 out of 10. You can see the detailed result. So you can go to model testing. So we didn't use the test set yet. So we are going to classify all the test data that we had sampled. This is the whole list for the test data. And once we click on classify all, we will see the results. We didn't use any of this data in the training set. Okay, so we can say that our machine learning model doesn't know any of these samples. So let's see the result. You can see the log on the right hand side. It's about to finish. And we will see the results for this test data. And you can see the model testing results. It's nearly 91%. And in this one, you can see that we had news as the least performing class, let's say. But the other 4 seems to be fine. And you can take a look at each sample, each test sample, and the results. Version, let's create our first version. I will leave the default settings. You can take a look at the log if you would like. And it's about to finish. And the job is completed. We can skip this one and continue. You can see our first version. It's training accuracy, test accuracy. Number of samples is listed here, so you can have different versions. Okay, the last step is the deployment, so you can deploy your impulse. So either you can create a library from this list, or you can build your firmware by selecting your firmware. Here we have our Nordic Thingy 53, so we will choose it. I will not be selecting Ion compiler, and I will be choosing unoptimized float 32, so you can see that it's currently selected. And I'm going to click on build to build my firmware to be uploaded on our Thingy 53 device. So it's building it. You can see the log. Building C object, memory usage. And okay, our firmware is ready, and you'll save it to a preferred folder. So it's a zip file, and I will save it here. Now that we have created our firmware from Edge Impulse, we can upload it to our device. Let's use NRF Connect for desktop and the programmer tool. But before that, make sure you put the device in DFU mode by pressing the switch 2 while turning the device on. So that puts the device in bootloader mode. So let's add our file. Let's click on browse and go to our firmware that we created with Edge Impulse. The zip file is selected. Now we are going to click on write. And we are going to click on write once again to upload the firmware to the device. It's going to take some time, but I trimmed those sections for you to be quick. And it's going to wait for 20 seconds for the device to be up again. So we programmed our Thingy 53 device with our firmware, and I'm connecting it to my laptop over serial connection. I could use the Bluetooth connection as well, but I believe there is a problem with the Bluetooth connection after I uploaded the firmware. So that's another topic that we need to discuss later on. So once I connect with the serial connection, I can use the AT commands to run the impulse. You will see that. So first let's write AT plus help to see all the commands. Now I'm going to use AT plus run impulse, and our impulse will run. And at the same time, we can see the TV screen that the thingy 53 is seeing. So we will be able to see how it makes the classification. This is a documentary about diving, so we don't think to have a good classification on this because we didn't train it. So this is fencing. It's classified as TV series, so we don't have any samples for those. Again, this is freestyle skiing. Now this is football, and it's first classified as basketball. Now it's football. You can see on the bottom of the serial connection. So it's classified as football 0.99. And we can have slight changes. You can see now another football game. So it's classified as football 0.99. Actually, the number of the classes is also important, and your training set about these classes is important. So maybe this is not a very good classification that we did 5 classes: basketball, football, news, snooker, TV series. Maybe we could say sports, news, TV series, movies, etc., and have much more bigger training sets. You can see that this one is again classified as football. In the beginning, this is classified as news. Now let's switch to football once again. We don't have a class for tennis, so it's half TV series, half football. That's the classification it did. So this is a movie, and it's classified as football. Now it has changed: snooker, TV series, and football. We didn't have training sets for movie, as you can recall. So this TV series is in the beginning classified as mostly football. Now some TV series, again some football. These are all related to the number of your samples in the training set and the choice of your classifications. Now this is a TV series, and first it's classified as football, then as TV series, half football, half TV series we can say, then TV series again. Another TV series, it's classified correctly as TV series 99%.